This is Unit 3, Triangles. Preview video 3.5, Triangle Congruency and Shortcuts. Don't skip this step. Take a moment, sit tall. Ready? In through the nose, inhale. Hold for 3. Birthday candle 5. Lower your shoulders. Ready? Inhale. Done. Close your eyes. Ready? Inhale. Birthday candle. Alrighty, guys, let's do this. Don't forget date, time, and location, as well as a parent or guardian sign-off. So for the past few classes, we've been talking about properties within a single triangle, things like two equal sides, two equal angles. We've been talking about the 4 triangle guts, if you will, the median, the altitude, perpendicular bisector, angle bisector, that's MAPA. Okay, now we're going to shift to the relationships between two triangles, specifically triangle congruency. Take a moment and read these vocabulary words out loud. When I say read out loud, you should have done that. Reading out loud on your own. It helps your brain remember. All right, so first we're going to talk about motion. There are 3 what are called rigid motions. These are motions you can take a shape, you can move them, and the before and the after is the exact same shape. One, take your hand like this, is called translation. Then you have, take your hands, make a butterfly, reflection. And the last one is rotation. Slide, flip, and turn. So when you take an image and you just slide it to the right, that's called translation. When an image is reflected like a mirror down the middle, that's called reflection. Slide, flip, flip is reflection. And of course, if you take an image and you rotate it about a pivot, that's called rotation. Slide, flip, turn. The fancy names are? All right, what I'd like you to do is simply name the motion you see here. Slide, flip, or turn, translation, reflection, rotation. Should take you about 30 seconds. Go. Okay, let's see how you did. This image was reflection. You should be getting out a red pen and you should be checking these if you got them correct. Check star smiley. If incorrect, I expect a little note. What do you want to remember? This is rotation. And then this is also reflection. Now, take a moment here. We're going to do this to a triangle. This triangle, ask yourself what's going on here. Translation would be the exact same triangle. So you know it's not translation. It's not a mirrored image like a butterfly, but you can see how these motions, see this one sweep and this one sweep, and the way you got it, it is rotated this way, counterclockwise. So this was a rotation counterclockwise, and when you take a triangle and you put it through translation, rotation, or reflection, you get completely congruent triangles. We want to match up the sides here. We're going to do this with me. Ready? CB, sweep it. Match it over here. R. So angle B is congruent to angle R. CC, double sweep. CS. And so angle C is congruent to angle S. Trace this with me. Always trace this with me. D is congruent to angle T. I want you to trace when I trace, please. That helps your brain feel that connection. Now we're going to do B to C. Notice the order. B to C, that's one sweep to double sweep. So you have to go the same order to match it exactly. That would be R, S, one sweep to double sweep. R, S, the segment. Now, if you went the other way, S to R, you would be incorrect because you have to align the corners. B is one sweep, R is one sweep, C is double sweep, S is double sweep. So you have to align the corners. Now we're going to do CD. Put your pencil on C. Go to D. We're going from double to triple. So we have to go double to triple. That would be ST. And then the last one, DB. Trace it. That's triple back to single. Trace it, triple back to single. That would be TR, segment. So when triangles are congruent, there are a total of 6 pairs of items congruent. So kind of put your hands like this and repeat after me. Say whole triangle equal. Then spread your fingers out. Say all the parts are equal. Whole triangle congruent. All the parts are congruent. Do it again. Whole triangle congruent. All the parts are congruent. So if I say that the whole triangle is, one triangle is wholly congruent to the other, then all the individual angles and side lengths are also congruent. Whole equal, parts equal. That has a fancy name, and then I'll give you the slang name here. The fancy name is this. Corresponding parts of congruent triangles are congruent. Corresponding parts are the parts that are in the corresponding position. So for example, B, angle B is the corresponding part to R. Side BC is the corresponding part to RS. So corresponding parts of congruent triangles, so if I tell you the triangles are congruent, are congruent. My slang for this is really simple. Go like this. Say whole equal, parts equal. If we say the whole triangles are congruent. You should be writing this down. Then all three angles are congruent. We're going to just go like this. All three corresponding angles are congruent. And all three segment sides. So that is segment congruent to segment is my icon right there. Wow, that's not coming out very well. Let's get a little closer here. One segment is congruent to the other. One segment is congruent to the other. One segment is congruent to the other. Okay, so if the whole triangles are equal, all the parts of the triangles are equal. So we're going to try this one. Ask yourself first, what is the motion? Remember, the motion there is translation, reflection, rotation. What is the motion from CAB to CJK? I'm going to wait 10 seconds. I'd like you to fill in that blank yourself. You should have said reflection, because think of it a mirror. It's reflecting. It's flipped over that. And now we're going to match up the sides. I am going to count to 20, and I want you, as fast as you can, to fill in those blanks as fast as you can. You've got 20 seconds. I'll give you 30 seconds. Okay, let's see how you did here. We would say angle C is congruent to angle C. That's called a reflexive angle. Talk about that in a moment here. Angle A, double sweep, is congruent to J, angle J, and B, triple sweep, goes with K. And then CA, you have to go to the order here. CA goes from single to double. On the other side, that should be CJ, this segment. A to B, that is double to triple. And double to triple would be JK, the segment. And then BC, that's triple back to single. And KC, triple back to single. So we see here that when triangles are congruent, there's a total of 6 pairs of items congruent. 3 sets of congruent sides and 3 sets of congruent angles. So when triangles are congruent, there's a total of 6 pairs of things congruent. So now we're going to talk about shortcuts. Everyone loves a shortcut. I just told you when triangles are equal, there's a total of 6 pairs of items congruent, 3 pairs of sides, 3 pairs of angles. What the shortcuts say is if you have a minimal of only these 3 items, a minimal of 3 in a certain order, then it forces the other 3 to be automatically congruent. So write the word minimum of 3 congruent. If you have a minimum of 3, then you get the other 3 automatically congruent. Minimum of 3. It has to be a certain order of things, and it forces the other three to automatically be congruent. That's why it's called a shortcut. So instead of showing a total of 6 pairs things congruent, you only have to show 3 in a certain order, and it forces the other 3 to also be congruent. And these 3 combos are called side, 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 angle, side, angle, and angle, angle, side. Now, because we're talking about congruency, the question is, how do you know when things are congruent? Okay, one is things are just marked congruent with hatch marks. For example, I have a segment there and I go like this, and it's already printed on the page, and you know that those 2 segments are congruent because it's marked ahead of time. Or if I gave you a triangle like this, and the triangle came with 2 sides marked equal, that's called pre-marked. But there's 3 additional sources of congruency, and I call these freebies. Freebies are things that are always congruent, but they're not marked for you. You have to hunt them down and mark them. And you've seen these before. These 3 freebies means when you see them, you mark them congruent, are vertical angles, also known as bow tie angles. When you see them, you always should mark them congruent. And when you mark something congruent, I want you to get in the habit. If you have a pair of angles, you put 1A for angles. 1A for angles, circle it. That means I have a pair of congruent angles. Go right down the middle of that triangle. It's like an apartment wall. That's called a reflexive side. It's a side that's shared by 2 triangles. It's exactly shared. Put your hands together, say a shared side. Put your hands together, shared side. So the triangle on the left and the triangle on the right share that. So we would mark that side congruent to itself, put a hatch mark. Technically, that's a pair of sides, circle with an S. And then here, I'd like you to trace the red triangle. Now trace the blue triangle. They exactly overlap and share this angle here, right here. They share that angle exactly. That's called a reflexive angle. Just like you have a shared side, you also have a shared angle. Those are always congruent, but never marked. So you have to watch out for those. Ready? I'm going to see if you can spot them. I'm going to count to 30. I want you to mark the freebies here. Ready? Go. Mark the freebies. Do it as fast as you can. Okay, let's see how you did here. So this is a reflexive side. So it's a side that's shared. So you should have hatch mark there, and you put an S. Technically, that's a pair of sides. Here, these 2 triangles share that angle right there. Let me just trace them. See, you have one triangle overlapping with another. They exactly share that angle. Hatch mark, A for angle. And then here, by far the most common would be vertical angles. You see them, you mark them, and you put a pair, A for a pair of angles. Now that you can spot your freebies, I'm going to introduce you to your shortcuts. Remember, the shortcuts say this. If the triangles are congruent, instead of having 3 pairs of sides, 3 pairs of angles, 6 items congruent, you only have to prove a special set of 3 congruent, and then it forces everything else to automatically be congruent. Your first shortcut is called side, side, side. Side, side, side says if you have 3 corresponding sides congruent, then all the other angles are congruent. Let me give you an example. So we watch out for our freebies. We have a freebie here right down the middle. We know that side is congruent, so I'm going to hatch mark it. And I'm going to put an S for sides. And then we're told these are congruent already. So that's another pair of sides. And then here you have a third pair, trace it, another pair of sides. So the shortcut that's being shown there is side, side, side. So if 3 corresponding sides, that should be plural, are congruent, then the other 3 pairs of angles are automatically congruent. That's what the shortcut says. Then you have what's called side angle side. It looks like this. If you get your hands out, if you have a pair of sides and then an angle and then another pair of sides and go like this, say squeeze the angle, squeeze the angle. The angle has to be squeezed between 2 different sides. So the concept of squeeze means it's between 2 distinct pairs of sides. That's called a squeeze angle. This shortcut is called side angle side. Here's an example. Okay, first we find our freebie, which is the vertical, and now we're going to mark it. Trace, trace. Here we have a pair of sides. Sweep, sweep. Here we have a pair of angles. Notice 1 letter for each pair. Angles. Here we have a pair of sides. So the side angle side shortcut is your second shortcut. Okay, looks like this shortcut printed on the bottom. So that's angle side angle. So it should come up here. Just put angle side angle here. And this shortcut says if I have a pair of angles, then a pair of sides, and then another pair of angles, angle, side, angle, angle, side, angle. Then the triangles are automatically congruent. Everything else is congruent. Okay, I call angle, side, angle the hamburger. Let me show you what I mean. So if you have 1 pair of angles, that would be these guys. A side, think of it as a hamburger patty, and then another pair of angles, angle, side, angle. That's what I'm visualizing with the hamburger. 1 pair of angles, side, a hot, juicy hamburger patty, from In-N-Out or Five Guys or wherever your favorite hamburger place is, and then another side. So it's angle, short, angle, angle, short, angle. Two angles with a side in between. This is what it would look like. Watch out for your freebies. I'm going to mark your freebies here. We have a pair of angles. Trace it with me. Pair of sides. And then we have another pair of angles, which are vertical. That is an example of the hamburger angle, side angle. Right here, take a look. We have one pair of angles. We have another pair of angles. And then we have a side, a reflexive side, that's sandwiched between two distinct pairs of angles. So this is an example of the hamburger angle, side, angle. Again, this goes to the other side. Our last one is called angle, angle, side. Our last shortcut is called angle, angle, side. This shortcut says if you have a pair of angles, then you have another pair of angles, and then you have a side, which is I call it the tail of only one angle. That spells angle. Oh, let me keep my colors consistent here. Angle, angle, side. I call that the tail because what I'm envisioning is a dog. You have angle, angle, and then you have a side. The side, angle, angle, side. The side is like the tail of one set of angles. So it's not sandwiched between like the hamburger. It's a tail, angle, angle, then a tail off the angle. Let me give you an example of that. Follow with me. So in this example, you were given a pair of angles, congruent already. Then you marked the vertical angles, which were right angles. Then you had a pair of sides already marked congruent. That's called angle, angle, side. You should be tracing with me. It's really important you do this tracing of everything. It helps your brain process the diagram. Once again, the side is only a tail of one of the angles. It's not even touching the other angle. It's not even touching this angle here. It doesn't touch. So that's why this is considered an angle, angle, side, or a tail. So this is angle, angle, side. If you read it like this, side, angle, angle, that's exactly the same thing. Both are okay. All right, now there's one combo, that shortcut that does not work. One combo. It's called the ambiguous case, meaning this specific combination doesn't force the triangles to be congruent. And that is side, side, angle. And you can see here, if you have a pair of congruent sides, so these sides are congruent and they're marked congruent, and you have an angle, so this spells side, side, angle. Notice the triangles are not congruent. They're not the same. So this side, side angle, side, side angle does not work as a shortcut. So what you want to remember, come up here, see side, side angle, cross it out. No bad words. spelled either way. Just remember that. Side, side angle. No bad words, spelled either way. Now, it doesn't work because it's a quote unquote bad word. It's just, I'm trying to help you remember side, side angle does not work as a shortcut. And you can just remember no bad words, quote unquote, spelled either way. Now, we are going to mark our freebies and determine which shortcut. And remember, our freebies are this: vertical angles, reflexive sides, and reflexive angles. Those are your freebies. Ready? I'm going to do this real slow. And the question is, mark your freebies, vertical angles, reflexive sides, reflexive angles. Determine if they're congruent by one of these shortcuts or if it does not force congruency. So let's take it real slow here. Let's start with our things that are already marked for us. Trace. When I pause, see if you can't beat me, say the word sides or angles. I'm going to go like this with my hand, like ta-da. Ready? Here we have a pair of sides. Sweep, sweep. Here we have a pair of angles. And then we have a reflexive apartment wall right there. We have a pair of sides. So this is an example of the side angle side triangle congruency shortcut. Ready? Let's try this one. Again, try to beat me. When I go like that, it's either sides or angles. It's good that you're interacting. Ready? And trace, trace. Here we have a pair of sides. Oh, we have a pair of vertical. We have a pair of angles. Here we have, ooh, looky there. See this? Okay, this is not in the same position as that. So on the left-hand side, you've got side angle side. On the right-hand side, look carefully. This reads side side angle. Okay, side angle side, the angles between. This one here reads side side angle. And remember, that does not work. So this one is not possible. That does not show congruency. Let's come down here. Start with your pre-marked. Sweep, sweep. We have a pair of angles. Here we have a pair of angles. And then we have a reflexive side. And if you look very carefully, that is a side, which is a tail of only one of the angles, the double sweep. So this reads angle, angle, side. This last one, trace, trace. We have a pair of sides. We have another pair of sides, and then we have a reflexive down the middle side. So this one reads side, side, side. You are going to pause the video and do this page exactly the same way on your own. It should take you maybe a minute if you know what you're doing. Ready? Pause the video. Get out your red pens, and we're going to correct here. And ready? This is a pair of angles. This is a pair of angles, and then you had a side. reflexive side in between, so that one reads angle, side, angle. This one, we have a pair of sides, and then you had a reflexive side down the middle. This one, we have a pair of angles, and you had a reflexive vertical angles, and then you had a side. So that one reads angle, angle, side, angle, angle, side. This one, we have a pair of angles, and we have another pair of angles, and we have a side sandwiched between. So this one is, or should have been, angle, side, angle. Big star smiley if you got that right. If you got something wrong, write yourself a note. What do you want to remember? Okay, there are now a total of 3 sources of congruency you need to remember. One is when you have what's called given information. It's just handed to you on a silver platter. 2 would be implied information, means if it's given, what else is true? And the last one, of course, is our freebies that you've been practicing. Freebies, given, implied, freebies, given, implied, freebies. I'm going to give you an example of each. Given. So given would be, well, it's just marked for you. See, it's directly on the diagram, remarked. So if it's marked congruent, it's congruent. It's like, it's congruent. Another thing, you could be told in a piece of information that it's given, but it's not marked. So for example here, angle B and E are marked congruent because you're given it as a given piece of information. So that's an example of given. Implied. Implied would look like this. You are told C is the midpoint of BE. So we trace BE and we're told that's a midpoint. What's implied would be B to C is congruent to E to C. That's implied. It's implied because of that piece of information. And in that case, you would say side. Here you say angles. So you have given information handed to you on a silver platter, remarked or just written. Implied, there's a piece of given information and it implies something else. And then you have your freebies, which means vertical angles are always congruent. A reflexive side is always congruent, even if they're not marked. And a reflexive angle, an angle that is shared by 2 specific things. We're going to pull it all together. And right here, I'm going to walk you through what's called gift. Gift. We are told that AC, the segment, bisects angle BCD. BCD, that's a bisector going that way. And it's a bisector of BAD. It's also a bisector going this way. Okay. And given, implied, because of the bisector, that means these 2 angles are congruent. These 2 angles are congruent. Freebies, what else is congruent here is this reflexive side down the middle. So look what shortcut is actually happening here. You can see that the shortcut here is angle, side, angle. It is a hamburger. Let's try this one. Given C is the midpoint of BE, so we trace BE. I'm going to circle C and just write the word midpoint. And AD, it's also going that way. You trace it, midpoint. Implied, if it's a midpoint going both ways, you got one set of sides and another set of sides. Freebies, vertical angles down the middle. And now you talk it through. Right here, I have a pair of sides. Here I have a pair of angles. Here I have another pair of sides. So the shortcut here is angle, side, angle. I'm going to show you how to do one last narrative. It's math meaning punchline. Ready? Let's see what we have here. We're going to do given. We're given the fact that AB and AD are congruent. And we're also given the fact that BC and CD are congruent, given. There's no really anything additional thing implied, but we do have a freebie down the middle here, right down the middle. We know that is a reflexive side. What's the shortcut we have here? We have a pair of sides. We have another pair of sides. And we have a third pair of sides. So we're going to do side, side, side. So a narrative proof would look like this. It's really, really simple. We are going to follow side, side, side. Ready? Math meaning punchline. Same thing. Math meaning punchline. Here's our math. We know that's true. Why? Because we're going to abbreviate. It is given. Check. That's true. Why? It's given. All right. This last one, I know this looks a little weird. It looks like this. It's called reflexive for a reason. Just like a reflection, we would write AC is congruent to AC because it's called the reflexive property. If you want to remind yourself, what does that mean? It's shared by both triangles. Side, side, side. The punchline is because of this shortcut, these triangles are equal now, congruent, excuse me, ABC, triangle ABC is congruent to triangle ADC because of side, side, side. Ta-da! That's called a narrative proof. I want you to summarize the 3 main things you want to remember from today's video.